Hi viewers, welcome you all to this particular session. In this session, I am given with a task of identifying the cations and anions present in this given mixture. So this is the mixture supplied to me by the lab personnel and I need to identify the cations and anions present in this particular salt mixture. For the systematic analysis of any salt mixture, we need to perform preliminary tests first. What are the preliminary tests? The preliminary tests include color, odor, action of heat, flame test, and then action of NaOH. Let us see all these tests one by one now. When I observe the color of this particular salt mixture, it is appearing green in color. Immediately it comes to my mind that it may be a nickel salt because generally nickel salts are green in color. It is dark green, therefore my inference will be maybe a nickel plus 2, may contain a nickel plus 2 ion. Okay, now I need to check the state of this particular salt, and the state of this particular salt is crystalline in nature. After this, I need to identify the order of this. I am getting a little bit of ammonia smell. I doubt that it may be an ammonium salt. Now I need to go for solubility test. What do I do for solubility test? I need to take small quantity of salt mixture in a test tube. So I have taken a test tube. I am taking small quantity of this salt mixture, very small quantity of this salt mixture in a test tube. Okay, I am checking the solubility of this particular salt mixture with distilled water first. I am adding distilled water a little bit and I am shaking. You see, the given salt mixture is completely soluble in cold water itself. If the salt mixture is soluble in cold water, ultimately it is also soluble in dilute HCl. Therefore, the given mixture is soluble in cold water and cold dilute HCl. That is my observation. Now, after this particular test, I need to go for action of heat. To perform an action of heat, I need to take a dry test tube. Small quantity of this given salt mixture is taken into that particular dry test tube. Very little quantity is sufficient. I need not take more quantity of salt here. Okay. Then what am I doing? I am heating this particular salt taken in the dry test tube with the help of Bunsen burner. Okay. From the action of heat, we could easily sense here the evolution of reddish brown color gas. It infers that it may be a nitrate salt, and we can also see the white sublimate that is formed on the walls of the test tube. So it indicates that it may be an ammonium salt. So these are the two valid observations that I've got during action of heat. Okay. Let's move on to flame color test. How do I do the flame color test? For flame color test, I'll take small quantity of the given mixture on a watch glass, and then it is made like paste with concentrated HCl, and the paste is introduced into the non-luminous flame of the Bunsen burner. Let us see that now. So this is the watch glass I have taken. I am taking small quantity of this particular salt mixture. Very small quantity is sufficient. I may be taking little excess, but you need not take, because for the sake of video I may be taking little excess. So I have taken small quantity of salt mixture on a watch glass, and I am making this like a paste with the help of concentrated hydrochloric acid. So this is the concentrated hydrochloric acid, and I am adding 1 or 2 drops, not more than that. 1 or 2 drops, sufficient. And I am making like a paste with the help of this glass rod. You see, it is made like a paste. I have taken the small quantity of this paste onto a glass rod, and I am introducing this into non-luminous flame of the Bunsen burner. I am getting flashes of green. Am I getting flashes of green here? Yes. So it may be indicating a nickel in the flame test. Okay. So these are the observations that I am going to get for nickel. So my inference is maybe a nickel plus 2, because I got a characteristic flashes of green flame in flame color test. Okay. Now I need to go for action of NaOH. For action of NaOH. For that I need to take a small quantity of given mixture into the test tube. This is a small quantity of given mixture taken into the test tube. So now I am adding sodium hydroxide solution to this salt mixture. Little quantity of sodium hydroxide I have added, and then I am basically heating this with the help of a test tube holder. Okay, I am heating. While I am heating, I can observe the smell of ammonia. So it may be an ammonium salt. I have taken hydrochloric acid. I dipped a glass rod in hydrochloric acid and I am putting. See, dense white fumes are observed. Because the liberated gas here is ammonia, I am getting the dense white fumes. See the beauty. So therefore, this is the indication for the presence of ammonium ion in the given mixture. Okay, right. After finishing the preliminary test, I need to go for the identification of anions first. So, during the identification of anions, the first test that I need to perform is test with dilute HCl. In this test, we may get some inference with respect to carbonate or acetate if they are present. Then I need to test with concentrated sulfuric acid for the anions like chloride, bromide in the cold condition and nitrate in the hot condition. If these tests are also negative, then I need to go for borate test and then phosphate test. Towards the end, I need to go for the test for sulfate ion. Now let us proceed with test with dilute HCl. For the identification of anions, I am taking small quantity of salt mixture in the test tube, and to this I am adding dilute hydrochloric acid. See, this is dilute hydrochloric acid I am adding. If there is carbonate ion, immediately I will be getting brisk effervescence. If there is acetate ion, then I may be observing vinegar smell after warming. Let us see whether I get brisk effervescence by the addition of dilute HCl to this salt mixture taken in a dry test tube. See, I have added. No brisk effervescence are observed, which means carbonate is absent. And I am heating this. For heating, always we need to use the holder. Okay. I am heating. I am warming this. I am warming. And I am observing the smell. I am not getting any smell of vinegar, which means acetate is also absent. Now, therefore, I need to go for test with concentrated sulfuric acid in the cold condition. For that, I need to take a dry test tube again. Test with concentrated sulfuric acid. I am taking small quantity of the given salt mixture, into the test tube. To this, few drops of concentrated sulfuric acid are added. Few drops. Just you observe. No colorless pungent vapors are evolved, which means chloride is absent. No reddish brown gas is also evolved, which means bromide is also absent. Now, let us check whether there is nitrate in this or not. For that, what should I do? I need to heat this particular given salt mixture. I am heating. So, what are the contents present in this particular test tube now? The given salt mixture and few drops of sulfuric acid, and now I am heating. Now you can clearly observe beautiful reddish brown vapors evolved. You can see them against my apron white background. Beautiful reddish brown vapors. Are you able to see them? Yes. So which indicates the presence of nitrate ion. So it is giving me an indication that my salt mixture may contain nitrate ion. So this is the first identification of the anion in the given mixture. Until now I got the identification for nitrate in the given salt mixture. So it must contain one more anion. That anion may be borate, phosphate or sulfate, we do not know. So we need to go systematically first to test for borate and then for phosphate and then towards the end for sulfate. Let us do those tests now. The test for borate. I would like to know whether there is borate ion present in this given salt mixture. For that, I am taking small quantity of this salt mixture into the test tube. Okay. I am taking small quantity of salt mixture in the test tube. To that, 1 ml of ethyl alcohol is added. This is ethyl alcohol I am taking, and I am adding 1 ml of ethyl alcohol to this salt. Then I am adding few drops of concentrated sulfuric acid. Concentrated sulfuric acid. This is concentrated sulfuric acid, and I am adding concentrated sulfuric acid few drops to this mixture. Acid. Care must be taken while adding concentrated sulfuric acid because there is ethyl alcohol present here. Now these contents are heated. While heating, always you try to project the test tube towards the sink area. That is the sink area. Therefore, try to direct your test tube towards the sink area. And you must be very, very careful while heating, especially when there is ethyl alcohol inside the test tube. I would like to see the vapors. There is no green edge color flame observed. There is no green edge color flame observed. So which indicates that no borate is present here. Let's do the test for phosphate. Let us find out whether there is phosphate ion present in the given salt mixture. I am taking a small quantity of salt in the test tube, and it is dissolved in concentrated nitric acid. See, I am taking concentrated nitric acid and I am dissolving this salt in minimum quantity of concentrated nitric acid, little amount, few drops, sufficient. So, dissolving this in few drops of concentrated nitric acid. Now I am adding ammonium molybdate solution. So this is ammonium molybdate solution I am adding. So if there is phosphate ion, I must observe a canary yellow color precipitate. I must observe a canary yellow color precipitate if there is phosphate. If I don't get a canary yellow precipitate, it implies phosphate is absent. So I am not getting any precipitate here, which means phosphate is absent. So ultimately, the absence of all the other ions except nitrate and is telling me that invariably my salt mixture contains sulfate. That is the indication for sulfate. Now we need to do the confirmatory test for the anions. Some anions are identified in the salt mixture. Only for those identified anions you need to perform the confirmatory test. So the identified anions for us in this given salt mixture are nitrate and sulfate. So I need to do the confirmatory test for nitrate and sulfate only. So let us start with the confirmatory test for nitrate first. Small quantity of salt is taken in the test tube. To that, 1 or 2 copper turnings are added. I am adding 1 or 2 copper turnings. Okay, and then I am adding few drops of concentrated sulfuric acid. I am adding few drops of concentrated sulfuric acid to this. I have added few drops of concentrated sulfuric acid. Now, without heating itself, I am getting the reddish brown vapors beautifully. Even if I heat also, I will get beautiful reddish brown vapors evolved. So this is the confirmatory test for nitrate. See, I am heating. I must get beautiful reddish brown vapors. You can see these reddish brown vapors against a white background. Clearly, Are you able to see them? Yes. So this is the confirmatory test for the presence of nitrate. So maybe nitrate or nitrate is present. Once we perform the wet test, once we get a positive wet test for nitrate, then we'll write in the inference nitrate is present. Okay, let us proceed with that. Do the wet test. I need to prepare sodium carbonate extract. How do I prepare sodium carbonate extract? For preparing sodium carbonate extract, I have taken 1 part of salt mixture and I have added 3 parts of sodium carbonate solid, and sufficient amount of distilled water is being added to this. Now I am adding distilled water. Sufficient amount of distilled water. I have added sufficient amount of distilled water. Now I am heating this particular mixture with the help of Bunsen burner by putting it to a holder. Slowly you need to heat. Slowly you need to heat. The solution sometimes bumps over. It may be spilling over on your neighbors. So therefore, while you are heating, utmost care must be taken. I need to centrifuge this or I need to filter this. The filtrate is called as sodium carbonate extract. Sodium carbonate extract I have prepared. How did I prepare? I have taken 1 part of the given salt mixture. I have added 3 parts of sodium carbonate solid. Sufficient amount of distilled water is added and the mixture is heated. And after heating, to get the filtrate, which is sodium carbonate extract. For that, I have taken a fresh test tube and a funnel with the filter paper inside it. See, I am slowly transferring the contents into the funnel. Now I got the sodium carbonate extract prepared. This sodium carbonate extract prepared by me should be utilized for doing the wet test. Wet test for nitrate and wet test for sulfate. Okay, right. Wet test for nitrate. I am taking small quantity of sodium carbonate extract which I have prepared into a fresh test tube. Small quantity of sodium carbonate extract is taken into a fresh test tube. Now I am adding dilute sulfuric acid to this to neutralize this sodium carbonate extract, which is basic in nature. Dilute sulfuric acid. So this is the dilute sulfuric acid I have, and I am neutralizing this sodium carbonate extract. Slowly. You need to add very slowly, very slowly. You see, bubbles are coming because neutralization is taking place. Neutralize. How long should I add? Sir, you must add until bubbling stops. Until the bubbling stops. Yeah, almost the bubbling is stopped now. Yes. Okay, I have taken sodium carbonate extract and neutralized it with dilute sulfuric acid. Now I am adding freshly prepared ferrous sulfate solution to this. I have taken ferrous sulfate and I have added enough amount of water. Now I am shaking to get freshly prepared ferrous sulfate solution. I am adding this freshly prepared ferrous sulfate solution to the sodium carbonate extract neutralized by dilute sulfuric acid. So I have added. Now I have to add concentrated sulfuric acid along the walls of the test tube. Then I must get a beautiful brown ring at the junction of the 2 layers. Concentrated sulfuric acid. So this is the concentrated sulfuric acid that I am adding to this to get the brown ring test. Let us see what happens. You must add consulfuric acid only along the walls of the test tube. See, beautiful brown ring that is formed at the junction of the 2 layers. See the beautiful brown ring that is formed. Did you see the brown ring? A beautiful brown ring is formed at the junction of the 2 layers. So this is the brown ring that is formed. Is it clear? Okay, fine. So this is confirming the presence of nitrate. The identification for sulfate, absence of all the remaining anions is the identification for the presence of sulfate. Now, therefore, let us confirm the presence of sulfate by doing a wet test. For that, I have taken sodium carbonate extract prepared by me. I am taking this sodium carbonate extract into a fresh test tube. Small quantity of sodium carbonate extract is taken into a fresh test tube. Okay, I have taken. I am neutralizing this with dilute hydrochloric acid. With dilute hydrochloric acid. See, during neutralization, you have to add slowly. See the bubbling? Because the sodium carbonate extract is basic in nature. When I add the acid, I am getting the neutralization. Yeah, bubbles have stopped. Therefore, I can stop adding the dilute hydrochloric acid. Now to this I have to add barium chloride solution. So this is sodium carbonate extract neutralized by dilute hydrochloric acid. For that I am adding barium chloride solution. I must get a white precipitate if there is sulfate ion. See, I got a beautiful white precipitate, which implies there is sulfate in the given salt mixture. Now this precipitate should be insoluble in concentrated HCl. Concentrated HCl I am taking, and this precipitate should be insoluble in concentrated HCl. I am adding concentrated HCl. You see whether it is soluble or not. I am adding. I have added concentrated HCl. The precipitate is not soluble, which implies sulfate is confirmed. Now that we have finished the analysis of anions, now we need to go for cation identification. Before we go for cation identification, we need to test for ammonium ion presence. For cation analysis, I told you that we need to perform tests for presence of ammonium ion. So we need to check the presence of ammonium ion. For that, we need to perform 3 tests. What are they? Number 1, action with NaOH. Number 2, the test with Nessler's reagent. And the third one is test with manganese chloride in H2O2 solution. So let us perform those tests for ammonium now. So I am taking a test tube. Small quantity of the salt mixture is taken into the test tube. So I am taking very little quantity and I am adding NaOH solution to this. So this is sodium hydroxide solution. I have taken small quantity of salt mixture in a test tube and I am adding little amount of sodium hydroxide to it. I have added little amount of sodium hydroxide. Now I am heating this. I am using the holder for heating, and in Bunsen burner I am heating. I told you while heating you need to be little bit careful. Okay, smell of ammonia. You are getting ammonia smell. So therefore maybe ammonium ion present in this particular given mixture. Now the presence of evolution of ammonia gas can be tested with a glass rod dipped in HCl. Let us see. I am putting it. You see the dense white fumes coming. The white fumes coming. So with a glass rod dipped in HCl, you are getting dense white fumes. So the presence of ammonium is detected here. I need to take small quantity of salt mixture in a test tube. Okay, I have taken small quantity of salt mixture in a test tube. To that I am adding sodium hydroxide. If I heat, then ammonia gas will be liberated. Okay, I have added sodium hydroxide, little amount, and then I am heating this. So I am heating this. Ammonia gas will be liberated. Ammonia gas is being liberated. Now I am adding Nessler's reagent to this. When I add Nessler's reagent, you must get a brown color precipitate. You see the formation of the precipitate? This is the beauty of this particular chocolate brown color precipitate formation by the addition of Nessler's reagent. Okay?
So very important test, very important test. This is a chocolate brown color precipitate obtained, confirming the presence of ammonium ion. For that, I am taking small quantity of the given salt mixture in a test tube. Okay, and I am adding sodium hydroxide. Okay. When I warm this, we are going to have the liberation of ammonia gas. So let us see that. So I am warming. What are the contents inside the test tube? Given salt mixture plus sodium hydroxide I am heating, and then there is liberation of ammonia gas. Now this should be treated with manganese chloride solution mixed with H2O2 in another test tube. So I am taking another test tube. To this I am adding manganese chloride. So this is manganese chloride. I have to prepare the solution of this. For that I am adding distilled water. So manganese chloride solution. I have prepared manganese chloride solution. Manganese chloride solution. To this I am adding little amount of H2O2. Very little amount. Very little. Don't add too much. H2O2 is a strong oxidizing agent. It can also of course act as a reducing agent. Don't add too much. Very important. Now I am adding this mixture of MnCl2 and H2O2 to the initial mixture containing salt plus sodium hydroxide after warming. I must get a brown color precipitate. You see, carefully you observe. You see the brown color precipitation? A beautiful brown color precipitate is formed. Fine.
After performing the test for ammonium ion, we need to go for general group separation table. For that, we need to prepare original salt solution. What is this? For this, I need to take little amount of salt mixture into a test tube, and I need to add a suitable solvent for preparing original salt solution. Because the given salt is soluble in water, cold water itself, I am going to prepare my original salt solution in distilled water itself. So let us look at that first.
I am taking a small quantity of given salt mixture into the test tube, and I am adding suitable solvent. Already we have checked that this particular salt mixture is being soluble in cold water itself in solubility test. So I am preparing little bit more amount of original mixture solution. Why? Because with this solution itself I am going to do the test for all the 6 group cations. So very important. Okay, so I prepare original salt solution. The given salt mixture is completely soluble. There is no residue at the bottom. So now I have got original salt solution. Now this solution should be taken into centrifuge test tube. Centrifuge test tube. Because for cation analysis I require centrifuge test tube. Centrifuge test tubes will be like this. Okay, they will be a little bit flattened. Okay, now they are a little bit sharpened at the bottom, unlike ordinary test tube. This is ordinary test tube and this is centrifuge test tube. Okay, so into that centrifuge test tube I am taking the original salt solution now. Okay, I have taken. Now I am adding the first group reagent to this. What is the first group reagent? The first group reagent is dilute HCl. I want to test whether first group cations are present in this given salt mixture or not. For that I have taken the original salt solution and I am adding dilute HCl. Dilute HCl is this one. If I get a precipitate, then it indicates the presence of first group cations. If I don't get precipitate, first group cations are absent. See, I have added, I am not getting any precipitate, which implies first group cations are absent. I have to add the second group reagent. What is second group reagent? Second group reagent is dilute HCl plus H2S gas. Already HCl solution is added to this original salt solution. Now I need to pass H2S gas through this. Now let us see what happens when H2S gas is passed into this. If there are second group cations, automatically you must get a precipitate. If there is no second group cation, you will not get any precipitate here. Let us see that. This is called Kipps apparatus and H2S outlet is this one. So I am basically passing H2S gas into the solution slowly. See, you can see clearly H2S gas is being bubbled, but you are not getting any precipitate, which means it indicates the absence of second group cations. The original salt mixture solution is initially mixed with dilute HCl. I did not get a precipitate. It indicates the absence of first group cations, and then I passed H2S gas through this. I did not get any precipitate, which indicates the absence of second group cations. Now I need to expel the H2S gas present in this solution. For that, I am adding 1 or 2 drops of concentrated nitric acid and then I need to heat. I am adding 1 or 2 drops of concentrated nitric acid and then I am heating this. I am heating to expel the H2S gas. Slowly I must heat. While heating, care must be taken. Very important. So I am expelling H2S gas. You can see bubbles. H2S gas is expelled from this because I did not get any precipitate in the second group. Now I am adding the third group reagent, namely ammonium chloride solid. See, I am adding ammonium chloride solid in excess. And then I am adding ammonia. See, I have added ammonia. But I did not get any precipitate here. I may be observing some color change or the other, but I am not getting any precipitate. Okay. Because third group cations are absent, now I have to pass H2S gas through this. So, for checking the presence of fourth group cations, let us see that. I am passing H2S gas slowly. You see a beautiful black color precipitate form. Did you see that? Yeah. So because you got a precipitate, it clearly indicates the presence of fourth group cations. We got a black precipitate. Which indicates the presence of fourth group cations. Now I am basically centrifuging this one to separate the residue of fourth group cations. The test tube having the fourth group residue, and I have taken one more test tube with distilled water because in the centrifuge mission, never ever I should keep odd number of test tubes. So always you have to keep the test tubes one opposite to the other like this. In this way, we have to keep in the opposite holders. Now we need to switch on this machine. Centrifuge machine is switched on now. Now, once the centrifugation is over, now see I got a residue, okay, and I got a centrifugate also. So now I need to separate the residue from the centrifugate. So this is the residue obtained for fourth group cations in the general group separation table. So this residue must be tested for fourth group cations and the centrifugate must be tested for the presence of next group cations. Okay, very important. So I have got a precipitate in the fourth group. This residue must be tested for fourth group cations and the centrifugate must be tested for fifth group cations and sixth group cations. Fine. What should I do for that? I have to take this particular centrifugate obtained after fourth group and heat it till the volume in the test tube is reduced to 1/3. Till the volume in the test tube is reduced to 1/3. I am I'm heating. I've heated this particular solution until the volume is reduced to 1/3. Okay. Now to this I'm adding little amount of ammonium carbonate. If I get a precipitate, then that is indicating the presence of fifth group cations. I'm adding little amount of ammonium carbonate. Little amount of ammonium carbonate. See, I did not get any precipitate, which indicates fifth group cations are absent. Now, this centrifugate is to be tested for sixth group cations. For that, and the only cation present in the sixth group is potassium. Therefore, to this I need to add little amount of picric acid. If I get an yellow precipitate, it indicates the presence of potassium. If I don't get yellow precipitate, see, I am not getting any yellow precipitate. It's only a coloration. The color of the picric acid is being reflected here. That's it. So I did not get any precipitate. So it indicates the absence of potassium ion. I have got a precipitate in the fourth group. This fourth group residue must be tested for the individual cations, namely it may be Zn plus 2 or Mn plus 2 or nickel plus 2. So these are the three cations as per the APCHI syllabus that we have in fourth group. But the black precipitate here indicates the presence of nickel plus 2. Because for zinc we must get a white precipitate, for manganese we get a flesh color precipitate, but the black color precipitate here indicates the presence of nickel. Anyhow, we are going to do the confirmation of nickel plus 2 ion with individual group separation table. For that, we proceed in this way. The individual group separation table for fourth group. This is the residue I got during general group separation table for fourth group cations. Now I am taking that residue, I am adding few drops of dilute HCl. I am adding few drops of dilute HCl, and then this particular mixture heated. Once it is heated, it must be centrifuged again. So I am heating. Must be very, very careful while heating. Okay, now it should be centrifuged. It should be centrifuged. Now let's go to the centrifuge machine. So I have placed them in the centrifuge machine. Now you see the beautiful black residue obtained after the centrifuging. So this indicates the presence of nickel or cobalt, but in our syllabus there is no cobalt, hence definitely we can say that nickel is present. And centrifugate may contain other cations like manganese or zinc. But mind you, already we have got ammonium ion in our mixture, therefore most preferably we have only nickel plus 2 in this particular group. Let us examine further. This is the residue I got after centrifugation. Now the residue indicates the presence of either cobalt or nickel, but cobalt salts are generally pink in color, but the salt mixture taken by us is green in color. Therefore, definitely this indicates the presence of nickel. Let us explore and confirm the presence of nickel plus 2 in this precipitate. For that, what should I do? I should basically take another centrifuge test tube, and the centrifugate is separated. the centrifugate may contain manganese or zinc. The centrifugate may contain manganese or zinc. The residue is to be tested for cobalt and nickel ions. So what I am doing, I am taking few drops of aqua regia and I am dissolving this precipitate in aqua regia. Aqua regia. Okay. I have added aqua regia. Now I am heating. I'm heating. So I have added aqua regia and I have heated this particular solution. So the heating must be continued until all the aqua regia is diminished or is vanished. Now this residue must be dissolved in minimum amount of water. I am slowly adding little amount of water. So I have added little amount of water and I dissolve that residue. Now it should be made into two parts. Okay, fine. First part should be tested for cobalt plus 2 ion, but because cobalt plus 2 is not there, I am directly doing a test for the presence of nickel. For this, I need to add dimethyl glyaxane. So I am taking little amount of dimethyl glyaxane. Okay, and I must add ammonia till I get a scarlet red color precipitate. Already I got a beautiful scarlet red precipitate, you could see. If I add little amount of ammonia, you should get beautiful precipitate. You see the beautiful scarlet red precipitate due to the presence of nickel. Is it not? So nickel plus 2 is confirmed.
So finally, in the given salt mixture, we came to know that the anions present are nitrate and sulfate, whereas the cations present are nickel plus 2 ion and ammonium ion. So we have reported both the cations as well as anions in this given salt mixture. So this is the complete analysis of the salt mixture given to us. Thank you.